Welcome to the video tutorial on how to use the standalone application for StatMiner. This tutorial will briefly show you how to work with StatMiner, like loading an example dataset, preparing the experimental design, and finally getting differential expression results based on default analysis settings. In this demonstration, we are going to use a simple dataset representing just few types of brain tissues: amygdala, cerebellum, and cortex. After choosing desired files from selected input folder, click on the Load button to import data. StatMiner automatically supports a wide range of qPCR data files from different platforms. It is recommended that you check the section on frequently asked questions to familiarize yourself with any further details to be included in the input files. The FAQ section also provides information on how to export data from the native software that comes with the platform. Next step is to define the experimental design of the analysis. As we can see, our example consists of 3 tissues plus a control group. Each tissue has been replicated 3 times. This configuration is already stored in an external file that we can retrieve at any time. That is all. StatMiner is now ready to run the analysis. However, let's have a brief look at the Project Options tools, where we can configure the set of parameters and quality controls of the analysis. These settings will help us to define how to deal with the technical and biological replicates, flags of poorly amplified CT values, and finally how to choose the best of controls to normalize our CT data. This configuration tool provides several levels of stringency, including a custom quality controls configuration, but in this example we are going to perform our analysis with the default settings proposed by StatMiner. We are now defining a control group from Differential Expression tab. We are ready and now have 2 options to run the analysis. We can execute a step-by-step analysis by following these workflow links, or let StatMiner perform automatic analysis based on the settings we have just defined. In this example, we are going to run it automatically by just clicking on this Click and Go button. It is important to know that the results in both working modes are completely equivalent. Once Click and Go analysis is finished, we can go and inspect one by one every intermediate result thanks to the Workflow Checklist panel on the left side. As we can see, this panel is being populated with intermediate results of the analysis that we can inspect later. For example, technical outlier distribution, sample correlation, DCT normalizing, etc. The panel on the right-hand side provides a step-by-step summary of the settings applied to the analysis and warnings that could arise after applying the quality controls over data. So here we are. The analysis has been done and the first report shows the detector behavior, that is, the relative quantification or the RQ of every detector along each tissue versus the control group. To better inspect these results, it is highly recommended to use the filtering tool available on the right-hand side of every report and the zooming tool from the toolbar. For instance, assuming we are interested in this detector GRM5, we can select it and use the zoom to get a better view of the RQ of the 3 targets versus the control group. As we can see now, in this case the level of expression along every tissue is quite similar. We are going to finish this tutorial by checking the differential expression report for one-on-one RQ comparisons. For example, amygdala tissue versus control group. From left to right, we can see the DCT profile of the samples that we are comparing. Where we have automatically filtered detectors with low expression, now we are resetting this automatic filter. The RQ bar chart that has been split into significant and non-significant values, and finally the RQ volcano plot. Please watch our subsequent tutorials to get a deeper understanding of StatMiner.